JP is our next speaker. He comes from New York Times, which is obvious all over. JP's interesting fact is that he did not know his first name was John until he went to kindergarten.
It was a rough first day, really rough first day. Can you hear me? Cool. All right. Hi, everybody. My name's JP. I'm a principal software engineer at the New York Times, where I spend most of my time working on the Crossword and the games platform at the New York Times. Today, I'm going to be talking us through a prototype we've been working on internally that allows people to share their crossword game with somebody else. Basically, it's collaborative crossword play, because if you're not familiar with the New York Times, the crossword gets harder throughout the week. Me personally, I'm just a Monday guy, but I need some friends to get me through anything beyond that. So we're going to talk about some technologies that we're using for some prototypes internally. Now, just a little bit of New York Times historical information. The New York Times crossword, it became part of the paper itself in 1942. In 1950, it became a daily occurrence in the paper. Very habituating, whatever, that's a bad word. When the website went digital in 1996, the crossword came as a digital offering not soon after. It was a Java applet at first, everybody's favorite technology. We took it over development of the platform internally in 2014, and now it's available on Android, on the Kindle or Play stores, on iTunes. It's available on the web, and it's available also as a Windows app. The cool thing that we do as our backend is that we allow you to play the crossword on any one of those devices, and we kind of hopefully seamlessly sync it from device to device for you. Starting in 2014, we also had a free daily mini crossword that actually increased our popularity and put some incredible load on our servers that our system couldn't handle. And because of that, we've been growing, the failing New York Times, and now we're up to 300,000, more than 300,000 paid subscribers on just the crossword product alone. That gives you access to the archive so you can play all the crosswords in the Will Shortzian era. The cool part about this, I think, is that we recently rewrote the entire platform in Go to move on the Google Cloud platform with zero downtime. All right. So as we wanted to make this game a real-time multiplayer crossword, there were some obvious problems that you run into when considering any kind of real-time game. First off, matchmaking. How is one random person on the internet going to find another random person on the internet or somebody they know and get them to join a same game? Once they're into this game, how are they going to sync this game state from one device to another? And then one topic that's really hard that I don't have time to talk about today is clocks, because nobody's clocks are in sync. And finally, a lot of data gets generated from playing a multiplayer game, so we want to make sure that we capture as much as we can and make it available to our analysts and our product folk. So Google has some really nice solutions in blog posts and reference architectures about real-time gaming. But for our needs, they're a little bit more complicated than what we needed. We're not building the next Halo or Destiny or anything like that. We're building a real-time crossword. It's just a grid. So as we started looking at these solutions, we decided we wanted to use a simpler solution. And we found that using many of the tools you just saw on that last slide, but really the special sauce we're going to use here is real-time database from Firebase. I'm going to talk through some of these solutions that we're using here, just in Google's own words to get you familiar with them before I get too deep into the meat of this. So Firebase's real-time database is a way to store and sync data in real time. Obviously, we're going to be using this for syncing game state from device to device, but we're also going to be using its custom auth mechanism that allows us to rely on our existing mechanisms of authentication at the New York Times. We're going to be using App Engine. We use it currently for most of our infrastructure. We use it because it's great auto-scaling capabilities. Also, it's amazing observabilities tools. By default, you get metrics, you get tracing, you get aggregated logs that combine your access logs with your application logs. Makes debugging a breeze. Has managed memcache for us. And in this scenario, we're actually going to use its byte signing mechanism to actually to manage creating of custom auth tokens for our users. Datastore is a highly scalable NoSQL database for your web and mobile applications. We currently use it for storing game state, but we also use it for storing puzzle data, pre-aggregated user statistics about their game or their lifetime of playing the crossword. And in this scenario, we're going to use it for matchmaking codes, either saving them, looking them up, getting people to find which game they need to join. PubSub is a simple, reliable, scalable foundation for stream analytics and event-driven computing systems. We're using it for event-driven or easy event sourcing, The idea is that sometimes something may happen and we need to do a number of things that may take a decent amount of time, and we don't necessarily need somebody to wait for that to happen synchronously. The nice thing about PubSub also, it offers push-style subscriptions. So for traditional PubSub frameworks, you may be used to polling to see when new notifications are available for you. In the way of PubSub and App Engine, you can set it up to just HTTP post securely to your application. BigQuery is a fast, economical, and fully managed data warehouse for large-scale analytics. We use it for basically aggregating things that are hard in a NoSQL database that you can imagine simple, like total solves versus attempt on the puzzle, or average solve time by day of the week. Or if you want to get down and help somebody possibly diagnose some issues that we're having, you can find a number of incorrect puzzles. Or really, whatever else our product and analyst people can come up with and they need to join with. Since all of the other New York Times analytics data is in there, it's really kind of a pool of data that our analysts can play around in. And finally, the reason why we're here today, right? Go. We use it. I use it especially because I think it's easy to read, it's easy to test, it's easy to deploy, it's fast, efficient, and fun, as you've heard a lot of people talk about. And we're also experimenting with its Gopher.js and Go mobile tooling, which I'll get into in a little bit here. So, the meat of things. We're going to talk about the actual lifetime of a game, how somebody could create a game, request their friends to join the game in progress. Once they're in there, they need to share game state as they play the game together. When the game is completed, we need a notification. We need to do something once the game is solved. And then, like I said, at the end, we need to capture all that data. So we need to aggregate and we need to archive a lot of stuff. So, creating a game, five-step process, right? As you imagine, the first thing, the host user that decides, hey, I want to play a game with somebody, the first thing they're going to do at the beginning of any kind of step in our auth or in our game is to just auth, log in, get some kind of a token on that device. So at least from my perspective, from the back end, I can see who you are. Two, they're going to just send us which puzzle they're wanting to play, along with a guest list of email addresses. Which users am I going to allow into my game? From there, that's when the Go APIs take over. Our backend will then look in the Datastore. It'll generate basically a shared code for somebody can use to just share with a friend and join the game later. So we need to create that token and store it in the Datastore for Lookup later. Then we need to reach into Firebase, set up initial state. And then finally, we need to generate a custom auth token so that that user can then connect to Firebase directly and have everything they need. So in 5 there, finally, the thing we're returning is a reference on where the client needs to reach into Firebase's real-time database, a token for them to log in with, and then the code that they can share with their friend. So just to show a little bit of how easy this is on Google's platform, I'm going to just throw some code at everybody here. So this is step 3. Basically, at the very top, you can imagine many number of ways of just generating a random 4-character code. From there, we need to see if that code has already been in use. So we have a quick query. I'll show you the guts of that function at another time here. And all that's doing is reaching into Datastore and says, does this code exist somewhere? Then we have a switch case, where we're just going to say what errors may have occurred from there. If there was no such entity, that means, hey, this code hasn't been used before. We are clear to use it. And then we're going to show on that next line, 18 and 19. On 18 there, we're actually creating a key, which is basically the primary key of Datastore. And then it's just a one-liner. There's no need to init a client. There's no need to pass any kind of credentials. You just put the data into the Datastore, and you're done. Finally, you'll just see some extra error handling there. If there was an error when we were attempting to look up the code, that means the code existed, so we need to try again. Imagine this is in a loop. And finally, just like any good Gopher, if an error did occur, we just let that thing bubble on up with a little bit of extra context. We didn't log it. Next step, we actually need to connect to Firebase. There's a nice third-party solution from our friend Zabawaba99 here. It's called FireGo. And similar to other Google's tooling, notice there's no credentials. There were no any kind of configuration. All I need to do is init the default Google client for OAuth connections, and then pass in App Engine's app ID. I didn't have to configure that. App Engine's got us for it. And then init the client. Very simple. This will work on my local host. This will work on App Engine. This will work on GKE. The exact same init. So now that we've initted our client, we need to get a reference of our Firebase real-time database. Now the thing about real-time database, the database itself is just a giant JSON tree. So when you want to access a particular piece of that database, you need to actually do a ref for it. As you can see there on line 62, basically what our ref will be is a machine, which is just a tag I'm calling this project. Then the user ID will be the next piece, and then finally the puzzle ID. And that will be just basically the section of that database on where this game for this host user is going to lie. Once we have our reference, we set that data with just a little bit of metadata. And specifically the thing that I want to call out here is that we're setting in the guest list, the people that are allowed to also access this game beyond the host. So we're going to go into a little bit of how Firebase's security actually works. So similar to your data structure within Firebase, when you define your security rules, it's just another JSON tree. I'll zoom in here to give it a little bit of easier reads. At the very highest part of it, we just declare that only an admin has global rights to do anything they want in the tree in this database, and that will kind of propagate to the rest of the tree. Next, you'll notice that the actual structure of that ref we mentioned before, the machine, then the user ID, then the puzzle ID, and then the guess. This is actually another piece of calling out within the code. It's going to, or within the database, we have a guest list, and we're only going to be allowing the admin or the user of this actual, or the host of this puzzle, to actually add additional guests as the time goes on. Finally, the really cool thing I wanted to show here is that you can reference within your security rules, you know, it says data.child guests. This is actually referencing that guest node within the same chunk of the database. And then it's also saying has child auth.token.email. And the idea there is that we passed in an email address for everybody's user token, so they know which their email is. And then Datastore or Firebase is actually reaching in and inspecting itself to see who has access to this puzzle or to this actual game. Self-referencing security setup, it's a fun phrase. But I think this is an extra cool feature that I think is worth calling out. Now, we have to create that token with that email in it. Luckily, Firebase has actually come out with their own managed client that they support themselves. And we can at least at this point in time just use it to generate custom auth tokens. So this is just another example of how you init the client. Once again, no credentials required. All I needed to pass in was my app ID, my project, and then it was able to use the environment to determine what it needed to connect from there. From there, on line 90, we will init a auth sub-client, I guess, of this base Firebase client. And then it's just a one-liner, custom token with claims. If you're familiar with JWTs, this custom token is really just a JWT at the end. So that's why that claims may sound familiar. It's a way for us to add additional key values to this token as we pass it along. So this is a one-liner. The one thing I wanted to show is that actually underneath the hood, this Firebase client is actually using build tags so that if it's on App Engine, it will actually just use this AE signer underneath the hood. So the library in general is much smaller here because all we needed to manage for crypto stuff when it comes to signing bytes or signing things is just that one function call. Similarly, we didn't need to deal with service account tokens or dealing with that kind of credential. It's just a simple function they provide for us. Right? So now at this point, we've accepted their request to create a game. We've saved it into Datastore. We've init the game state at Firebase, generated a custom token, and responded out to our host. Cool. Now we need to actually join the game in progress. Looks very similar. However, we're just going to be pulling things out of the databases instead of putting them in. So the first thing that user is going to do is they're going to use, to join the game, they're going to take that 4-character code that was shared with them by their friend. They will pass that along to us. We'll look that up in Datastore. If it's good, then what we're going to do is reach into Firebase, aggregate some game state, and then hand them a response that has, once again, that reference on where they need to look into Firebase, their auth token that you need to use to connect, and then some initial game state. So this is just the other side of that function that we saw earlier to actually look up a game, just a more example of how easy it is to use Datastore on App Engine here. No client to init, I just simply said new query, threw a filter on it and said, give me all my datas. Just a quick, easy way to prototype things, and in general, just put in production. So the hard part about this, though, number 4, is that we need to aggregate all that game state that possibly is on the server already. There could be thousands and thousands of moves out there. Somebody could have been moving around on this puzzle for days, right? So when we first created our prototype, the initial version of it actually tried to aggregate and pull all game data in as it loaded up the page. That led to some awkward pauses where you'd be sitting there for a good 30, 45 seconds waiting for it to catch up and finally able to play. We actually decided it was actually better and faster for us to aggregate this game state on the server side so that we could then just serve up where they need to start now and listen just to changes coming across the pipe from like the last 30 seconds on. This does represent the problem that suddenly we need to have shared game logic on the server and all of the clients. And so for our experiment here, we started using, at least the prototype we're going to be playing around with today, is using heavily on Gopher.js. We also have the idea that we're also going to be looking to use this with Go Mobile in the future. Now the idea is that we wanted to have this shared game state, or the game logic. And we just like to think of it as a black box I'm calling the game machine. And the idea is at the very beginning of it, you can just hand it a little bit of puzzle data, just the JSON or the protobuf of the data. And it will just hand you a representation of the first initial state of the board with the initial cursor set and all the secondary highlights. This way we don't have to implement this stuff every single time. And then similarly, you can come at it and say, hey, they just hit the letter A in the keyboard. Well, the game machine knows where the cursor is, so it knows to put A in the appropriate slot, and it knows to advance the cursor using our handy-dandy cursor logic. So underneath the hood, this is really just what the game machine looks like. You init your game, and then it has all these actions that we've exposed as methods. In Gopher.js or Go Mobile, the idea is that these will just show up as additional methods that you can call. For example, add guess action, it takes a value of what the user actually guessed and if they had the pencil flag on, or add select action, that just saying, hey, the user clicked on this cell at this index. From a client perspective, all they have to really implement is this renderer. They pass this into the game machine, and then we just know that every single time we feel that the game state has changed, we just pass it to them and say, render this. That has all sorts of handy things on it, like an SVG and whatnot, so rendering is actually quite simple. Similarly, once you realize that we need to be emitting these changes across the pipe. So if you imagine the game machine not only is telling you, hey, render this, but it also has a hook that you can say, hey, listen for changes as they are coming in, so that the client can accept them from the games machine and then just emit them over the pipe to Firebase. So for an example here, when I hit A, it emitted a change for user 1 and just said, hey, there was a guess A on index 0. Similarly, changes could be coming in across the pipe from other players. So the game machine also has a hook for basically add changes, so that as a change from user 2 comes in and they've selected basically cell index number 6 in direction down, we're able to put that nice light green square on there indicating, hey, this is a different cursor, a different user on your puzzle with you. Underneath the hood, those two hooks are actually just called add change and set change listener. The nice thing about Go and Gopher.js and all of this is that since all of these changes could be coming in asynchronously at any given time, we can just throw a mutex on it. Just throw a mutex lock and a defer, and suddenly everything is serialized and the board can only change one thing at a time. Similarly, like that set change listener, you just hand me a func, and then as I see changes, I'm just going to be calling you with them so that it's simple enough that they just have to hand them over to Firebase. Not much work they need to do on their end. So this is what it looks like, just to aggregate all that game state on the backside, on the server side. I get that same reference to the game, except for the steps, which is actually where we're holding all of the changes in the game. I take a snapshot of the board, or of those steps at this given time on line 22. Say, hey, here's a map string interface. We're being loose, this is a prototype, sorry. And then the one thing that I want to call out here is that actually we found that there is an issue when it comes to, it's not necessarily an issue, it's just something you have to work around. In Go Mobile, you're not allowed to expose slices or map types to the other language, which can make things a little bit difficult if you're dealing with complex data structures like a board or a puzzle. So to kind of get around this, and since our traffic isn't anything like a Google scale when it comes to the crossword, we're actually totally fine with just marshalling JSON and passing raw JSON back around the pipe. So when it comes to JavaScript to Go or Android to Go, it's really just JSON strings back and forth. Right. So now we've actually been able to aggregate our game state, generate the token, find the actual game you need to have, and then hand it back to our client. At this point, now our clients are fine to actually share game state. At this point, it's also really nice that, if you'll notice that my code is in this picture at the most part, except for the game machine. Our API just kind of steps back and lets Firebase take over handling game state sharing. The idea is that as one user adds a guess to their game, someone is listening for children being added to that part of the node, and Firebase just emits that change back to everyone. So you'll put your change out there and immediately receive your change back. You can ignore it because you know your user ID, but then you know as other changes are coming in from all your players that are joining you, it's just a simple stream of changes that you can just pass to the game machine and render. So underneath the hood, this is actually what it looks like within Firebase's real-time database. This is actually using Google Auth, so that's like one of my Google IDs apparently. So you'll see it's the user ID, the puzzle ID, and then the steps. Internally there though, Firebase doesn't actually allow you to build or use arrays. So it actually is just an object, and as you add a child to it, it generates one of those random IDs like you see there, -KTL and blah, 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 blah. So for an example, this is what a single change will look like across the pipe for a user who has just selected a particular cell. So my device at that particular Unix time, and that's my user ID, I was on index or cell number 11, I was pointing in a cross direction, and that was a cursor change. On the other side of things, this is like somebody entering a guess. I've collapsed the key here, so you'll see the guess of what actually the guess was, where that guess ended up being on index 1. But at that same time, the cursor is moved as a result of you entering that guess. So we have a new dir, a new index. Basically, it's all nice encapsulated that everything you would need to render that cursor move and that guess is all in one little payload. Right. Cruising. So finally, the game is completed. At that point, we need to do some stuff. We need to do a lot of different things. We need to aggregate that data. We need to do all sorts of things. However, it would be kind of mean for us to force the user to sit and wait for all that stuff to happen right when they published it. And also, that's a very heavy call. And a lot of times, we get people that are really excited and, I solved the puzzle, close the laptop. Or I solved the puzzle, kill that tab. So we want to make sure this call is very small as possible. So all it's going to be is the device is if they leave the game or if they solve the game, just send us a tiny little notification saying, hey, go look at things. But we don't want to do that right now, so we're leaning on PubSub and event sourcing. So as that game is completed, they just send us a little notification, and we just pass that notification right along to PubSub. We publish it out to a topic. And this is finally where we can start aggregating that data. PubSub is really nice in that it's going to be doing push style, so it's just HTTP posts to our service. And if we screw up, which happens, PubSub will retry our things for us and maintain them in the queue. So just an example of a few things that may need to happen here. One of the subscribers is going to reach into Firebase once it's received the notification. It will then aggregate that specific user's game stats, how many reveals, how many checks, how many guesses within the puzzle did they contribute, and then store that aggregated state into Datastore for lookups later or something like %complete. Secondly, we don't necessarily need to hold on to all these game changes forever. So if a game was completed, we need to basically set a flag in the Datastore that says, hey, this game for this user on this puzzle ID is completed. Maybe in a week, go ahead and run a cron job that's going to say, hey, these are stale puzzles. We can go ahead and just delete them from real-time database. And then finally, we need to get that data into BigQuery. So there's just one more worker, just reaches into Firebase, and then just streams the data directly into BigQuery so that our analysts can come back later, or if somebody complains and saying something wrong with their puzzle, we can see, you actually typed a 0 instead of the letter O. That happens a lot. Oh, I help a lot of people with that one. All right, so this is the meat of it. We cruise pretty fast. This is the scary part now. I've got a live demo. Please feel free to bring out your devices, your cell phones. Hopefully it's mobile friendly. And we're going to solve a crossword together. There you go. So please feel free to join. This is actually using Google Auth underneath the hood. So when you see that nice App Engine message, are you okay with logging in? Feel free to just say, yes, it's okay. And I'll also give the disclaimer that I wrote the JavaScript on this, so I didn't really add the whole handling for on disconnect in case you do lose your connection. So if you start seeing lagginess, there we go. There's people in here now. So let's solve it, all right? I'm going to do the hard one. Cable, TV. What else are we going to get? You guys are cruising, all right. Oh, this is going to be a post over here. No, that's not right. So let's see, post. Oh, this is on cable. That's what it's going to be, on.
Everybody keeps changing all the answers. Yeah.
All the programs were really bad at this.
Oh my God!
So this is by far the largest audience I've done this with. I've done this with about 40 people before, but generally those people were good at crosswords. This is going to be Penguin. This is fun. On cable.
How many times have you typed that?
Shh. It's post. Tenders.
Stop.
From sea to shining sea. All right. This is Scarlet. Oh, you guys are all fighting with each other now. Oh no. Oh no. Pinot. Ted Pinot. Thank you for being alpha testers. Kill me. Come on, Penguin. You're back.
At what point are you gonna sit down?
Shoot, we got 5 minutes. You want to keep
I
going?
mean, this is never gonna finish.
That's true. This is all people can play nice. All right. All right, everybody. Well, this is it. I really hope that we could have done it. It was close. I'm going to leave it on, and I'll just kind of answer questions as y'all noodle around on this.
Or maybe don't leave it on. Who knows what someone's going to type?
Yeah,
It's just
I
like-
might go there.
Well, we will take questions, though.
Yeah. So thank you,
Thank you,
everybody.
JP. Oh, really, take that.
Yeah.
Who knew the crossword puzzle involved so much tech?
I did.
Oh, I did too, because I knew what the talk was going to be. That was pretty awesome.
All right, thanks. Do we have questions for JP?
Did I miss anything before JP's talk?
Yeah.
Oh, okay.
Yeah. We announced the winners.
Oh, okay.
All right. Thanks,
We do
everybody.
have a question.
Oh, shoot.
When does it launch?
Still waiting on design for that one. Basically, this is my proof that we can do it, and now it's just more of scheduling a few other things. We do have some other things that are in the pipe that have a little bit higher priority, comparative things, so like when you solve a crossword that you want to share your time with a friend. So I would say that I'm pressuring product to do this early next year.
Awesome.
Cool?
We got one more question in the back here.
Shoot.
What design features do you have to prevent players from messing up other players' games?
What design features do you have to prevent other players from messing up other players' games?
So the idea was that
Humanity.
Yeah, that's what I
humanity.
thought.
Normally what we'll do is that we won't offer people's games and open them up to the public. So it's all about hopefully you trust the person you're sharing your crossword with. Usually I'm just bringing in ringers. Like I said, I'm a Monday guy.
All right.
Any?
All right, thank you, JP.
All right.
Thank you very much.